Okay, so I've got this program, and notice I've got a prototype up here. It's just saying I'm going to change X. I'm going to send it a parameter. Here's main, the driver. I'm starting X's value off at 50. I'm printing what X's value is in main, and I'm going to then call that function. That's going to change X's value. And then I'm going to print out what X's value is in main again. Now think with me, if the function call on line 12, if it changes the value of X, I should get two different numbers from line 11 to line 13. So keep that in mind. Let's look at this function down here. This is like you've been writing them. Notice I've got a parameter called X, and I'm changing X's value on line 17. I'm making it 25 times as big. I'm printing out what it is in the function. After that function ends, it'll go back up to line 13, and it'll say what the value of it is. Anybody got any guesses what it's going to be? What's 25 times 50? 1,250?
Yes.
Well, let's run it and see. All right, let's try it again. There we go. Notice
Because it's a void.
it did not change the value of X in main. What does that tell us about this function? Hannah?
You left out the ampersand.
Well, the way it is right now, what does it tell us?
It's passed by value.
Yeah, thank you. X here is passed by value. Well, what do we know about that?
You can't change.
What does it mean to pass by value?
It's a copy of it.
Right, it's a copy. So that means I can do anything I want to this copy that I'm sending to it. So to the copy, I'm multiplying it by 25. I'm printing it out. And then what happens to the X? What is the scope of a parameter? What's the lifetime of a parameter?
Just the function.
You're exactly right, in that function. Only in that function. Okay, so that didn't work out well. Now I'm going to change it just a little bit. So I'm going to come down here and close this thing. I'm going to go up, and in my prototype, I'm going to put this, the ampersand, which means I'm sending it a reference to an int. And then down here, I'm going to do the same kind of thing. That's the only difference I'm making here. What's it not like in here? Oh, let's run it and see if it even compiles. It did. Look what I got.
So the endings that change permanently? The
Yeah, look, it physically changed what X is in the main.
So that's how you're supposed to look. Okay.
There are sometimes I want to do that. Most of the time, I don't. Think about it like this. If I wanted to change something about Joshua's house, all right? It's probably a really good house. I don't know. I've never seen it. But what if I wanted to change something about it? I couldn't do it from here. I would need what? The address of his house. And then if I go to that address, I can change something. Well, think of this in a way as you're sending this reference is kind of like, not totally, if you go on in programming, it's a little bit different, but it's kind of like sending the address of the original variable. If I've got that original variable's address, I can go there and change it, and that's what's going on here. Again, most of the time you don't want to do that, because if you read in the book, it said, I'm not trying to slap you down or anything, but in the text, and it's correct, if you let this function change something outside that function, you're giving it a lot of power. Most always, we want the functions to be self-contained and not being able to reach outside of themselves and change something. By using reference parameters, and this is a reference parameter, why? Because it refers to the original thing. You're not just sending a copy, you're sending the address of the original thing, kind of. If you go on in programming, you'll learn about things called pointers. They're in chapter 9. They're weird gadgets. They'll drive you crazier than you already are. But this is certainly in the family of being like a pointer pointing to the original thing. So if you just remember, if you send a reference, you're letting me have the keys to Joshua's house to go in there and do what I want to. That's a scary, scary thought. Okay, stop right there. Raise it.
I don't remember what I was going to say.
Do what?
I don't remember what I was going to say.
Well, you're getting older, your mind starts to go. Thank you. We're talking about reference parameters, Jay. Okay, if it comes back to you, holler. All right, does that explain reference parameters enough? Well, maybe. Let's do this. Int get value. A couple of you have had questions about things like this. Notice no parameter. I'm wiping this out. See, aren't you glad you don't have to copy that? Okay, I'm losing that. Notice I'm not sending this function any parameters, but sending me back an int. And so down here in main, I can say int x, y, z. And then I can say, how would I get the value for x? I could say x gets its value from this function. And I could say y gets its value from what now?
From the same program.
Right, from the same function. Notice, it's the same function, I'm just calling it repeatedly. And several of you have emailed me saying, well, how am I supposed to, in the function programs, how am I supposed to get the data for the variables? Just like this. You have one function that you call as many times as you need to get those values. And so then I could have an output function, print stuff, and send it x, y, and z. All right, so I need another prototype up here. Void, because I'm not sending anything back. All right, so then I come down and I actually write those functions. So down here, I would probably put what? Int, get value, no parameters. Now see, basically, I've got a stub right there. If I just put return 1, it's going to send me back a 1 for each of those, right? But I could test to see if it's actually sending something back. And then I've got void, print stuff. And I've got int x, int y, int z. Okay, so I've got 2 stubs down here. Let's start filling them in. Y'all see that if I just put return some number that I could run my program? As soon as I print something out down here. Okay, so C out. Enter a value. Cn, I don't have anything here to store it in, so I'll just put n. And then return n. So that means I've got to declare a variable up here, a local variable. Now then, look at that. Some of you might be thinking, well, wait a minute. N, that's not X or Y or Z. That's not going to work. Well, yes it is, because N is just the variable that we're letting them type their value into. As soon as we return it, notice up here on line 13, the first time I call it, it's being stored into X. The second time I call that function, whatever they type is being stored into Y. And the third time, whatever they type is being stored into Z.
So how do you do 3 different values?
We're going to have 3 different values right there.
Like if you were to do 12, 15, and 13, like how do you do it?
I'll show you. I'll show you. Would this run just like this?
Yeah.
Yes, because this stub down here, I'm not telling it to do anything. I'm sending it parameters, it's getting parameters. I'm sending it arguments, it's getting parameters, and so we ought to be good. So if I just ran this, but I don't want to. I want to run the debugger. So I'm going to put this breakpoint right there, and I'm going to hit F5. 5. So what do you want to put in there, Brenda?
12.
Okay, so we'll put 12. Now, let's look at what X is. I put the cursor over it. It's 12. I can come down here and look at X. It's 12. Okay, so far so good. I hit F10, and my program comes up and says enter value. Brenda?
15.
Look at Y. So you got to think of this as that function is handing you something. It's going, here's an N, and what do you want to do with it? The first time, the driver, main, says, oh, I'll take it and I'll store it into X.
Oh.
Okay.
Okay.
Well, she told me 15.
Oh, I don't know, I just picked a random number.
Oh.
And so if I hit F10 again, my program comes up and I can put, like Brenna's age, 28. Notice Z is 28.
I get it now. Okay, so it reruns every time you call it.
That's the beauty of having a function, right?
Makes so much sense.
Good.
Okay.
Okay, so I can stop the debugger here. Now y'all, I had to call that function 3 times to get 3 values. What if I didn't want to do that? Let's look at another use of reference parameters. I can go back up here and modify this. I can say get values with an S, and I can say I'm going to send it 3 reference parameters. Now watch out. This can get real attractive looking, but it can cause you a lot of problems. And so now I'm going to make this void, because technically I'm not sending anything back. I'm going to let this thing modify X, Y, and Z right here. So I'm just going to say get values. You with me, Luke? All right. So I'm going to send it X, Y, and Z. Now this, hang with me. Now what have I done? Get values, I'm sending it 3 reference parameters. So I'm going to put, here's an integer reference called X. Doesn't matter what I name it now. I could call it these A, B, and C and it'd still work. Notice what I've got to do though. I've got to put this reference symbol for each of them. Now then down here I can say, I'll take this out. I think you're going to be glad there's a video of this one. Enter 3 values. And I can say CN X, Y, and maybe not that, Z. And again, if my parameter names were A, B, and C, remember A would be referring to X, Y would be, B would be referring to Y, and so on. I'm not returning anything. Okay, now think about this after what you've read. Look at main. Can I tell in main that I'm sending reference parameters?
No.
No, I cannot. This looks just like it did. What I changed was the function prototype, and the actual function heading. Let's run it, see what we get. I'm going to debug it again. So just F5. Okay, notice if you look down here at the bottom, X, Y, and Z just have junk values. The next thing that's going to happen is I'm going to get into that function called get values. So I hit F10. That's asking me for 3 values. You're our value person, Brenna.
All right, 17,
17.
21, 34.
Okay, I'm getting all 3 values in one function. Look what X, Y, and Z are.
So why wouldn't you do that?
Wait, aren't they all the same?
They aren't. 17, 21, 34. Why wouldn't I want to do that?
Yeah.
I'll go back to what I said before. Do you want to give me the keys to Joshua's house?
Okay.
You are giving the keys to 3 variables to this one function. What if that function didn't, what if it's longer than just what it is and it accidentally did something to one of them? Bad news. When you go back to try and debug it, good luck.
So it just makes it like harder to debug?
Harder to debug, and this function depends greatly on these variables, right?
Okay, so it just, and like once the programs get longer, it'll make it more difficult to use.
Yeah.
Okay.
Now, and think of something else. If I'm writing a program and this function was in a library, what if I put this function in a library where you don't even see it, and you don't realize that these are reference parameters, and you go up here in your program and you call the function like this? You could get blindsided because it's actually going to change those variables, and you might not realize it, and the rest of your program, and then when you go back and start debugging, it's like, what happened? Yeah. Imagine 10,000 line program, and this function is just waiting down there like a shark. So if you are going to do something like this, then what you would have to do is the documentation that you would put as part of that library would say, these are reference parameters, watch out.
Okay.
Okay? Any other question about reference parameters? That's what you're doing, is you're saying, I'm giving you access to the original thing, not a copy. Here you go, Laddie, take the original Declaration of Independence and run through the car wash with it.
They're kind of like global variables, which is like 2 functions, right?
No. A global variable would be outside of any function. So think of X, Y, and Z up there. They're local variables to main. So
But like they're like the same idea in the sense like if you change it, you change it.
except with these, you're giving that function access to them. With a global variable, it automatically has access to it. Yeah, that's one way of looking at it, Gracie. Anybody else? And the text spent a lot of time on this with good reason. Again, y'all, use reference parameters sparingly. Most always you don't need them. What did this save me? It saved me running the same function 3 times to get 3 variables. What did I give up? Well, some control in that program. And you're going, well, not really, Ladley, because you're writing a program and you can see what it's doing. Yeah, but in the real world, we might be part of a team that's writing 30 different functions and another team's writing 50 different functions, and somebody's going to put all this together. And we don't want something that we wrote to trash out everybody's stuff. So it works. I've used them before. You can use them, but unless the specifications of the program say otherwise. But use them real sparingly and know what you're doing. Something else we read about.
Exit function.
Hmm?
The exit.
The exit function.
Overloading.
Okay, and overloading. Let's put the exit function in here. What if instead of printing anything out, I just put exit?
Then it'll end it, right?
Yeah, and then below that I put, see, hope you're well. Are you ever gonna get my good wishes?
No.
Nope. So let me stop the debugger, and take away the breakpoint here. So to use that exit function, you've got to include, I think it's C standard live. Okay, thank you. Still not liking something, what's it saying? Too few arguments, so I can say exit 0 if I want to. I believe if I put void for main, it would let me get by without anything in here. So let's just run this program. Control F5. Enter 3 values, 1, 2, 3, and it's over. Because that exit is like, oh, I don't think your heart machine's working well. Let's just jerk the plug out of the wall. Because that's in effect what you do. When you put exit, it means goodbye.
Can you explain how to use the book talks about exit? Exit to exit.
Yeah, you can remember when your program ends, you can send codes back to Windows. Well, this right here is the same as return 0. It's just not return. It's just you're getting out of the whole program. It's over. So no matter what your program's done up to then, it's gone. So watch out for that. Overloading. Unless we got something else about the exit function. All right, let's write overloaded functions. So I'm going to erase these. Int get area. I'm going to send it 2 ints. Int get area. I'm going to send it 2 ints. Now hold on. What's a compiler going to say about this?
It doesn't know which function to call.
Yeah, it's like if Claudia said, which way do I go to get to the main hall? I go, either turn left or turn left. You might get confused. I've got 2 functions with the same name, but watch what happens if I do this. Then no confusion because the parameters have changed. So let's get rid of all of that. Let's do one more. Double int area. And I'll send it, no, I'm going to send int, and watch what happens. That's a mistake. Look what it's saying. It can't distinguish between this and one of the others, like the one on top. Well, what if I send it a double here? Okay, so let's come down here. Let's say double A3, or area 3. And I want some ints in here too. So ints, area 1, area 2. Okay, and I suppose I say area 1 equals get area. Get area. See if I can spell that. And I go, I'm going to send it 10 and 5. Now maybe this one is going to be for a rectangle. And maybe this one's going to be for, what kind of area uses three numbers?
Length times height.
For a trapezoid? All that good geometry that they slaved over with you folks?
Oh my God.
Yeah, geometry was.
Geometry has to be the biggest waste on the planet. Okay.
It really is.
It's not actually, you know it's life.
And this,
When do I need to measure a triangle?
That's what
this might be for a
Tell
triangle.
me one day in your life you need to measure an
I
angle.
think it's
Oh, wait, I got an idea. How about this?
Really? For one of these that you are-
Well, not going to, so what else?
Okay, so I don't need this to be a double. All right, change the page just a little bit. All three of these areas are going to be ends. So I say area 1, get area like that. I say area 2. Y'all need something to keep your little hands busy.
Yes.
Okay, I'll start bringing color in pages, but right now, let's work on this. Okay, so get area, and I'm going to send it 6, 8, 10. And area 3 is going to be get area 7. Now, y'all, here's examples of an overloaded functions. What makes them overloaded?
They have the same name.
Yeah, that's the same name, but different,
Different parameters.
Yep. Bunch of you are saying it. Same name, but different parameters. And notice I'm using all numbers here, but what if one of these parameters was a string? What if one of them was a chart? You know, as long as the parameters are in a different order, that's all it's going to take. So here's an example where we got a different number of parameters. Yes, ma'am?
what does that print out? Like, what do you mean 10 or 5? Would you multiply it? Or would it just be like?
If we write these correctly, it will.
We haven't written the functions yet for it.
Yeah, we haven't written the functions. We always write name first.
Are you just saying that the area 1 will have like 10 and 5 somewhere?
The area of this one should be 50, right?
Yes.
If it's for a rectangle. So let's write these. So I'm coming down here, I'm taking away this on each of them.
It's a mook.
All right, got some stubs. All right, this one, int, I got to give them names, so I'll call this one length. This one width, because it's for a rectangle. This one, oh well, what is it for trapezoid? Base 1?
Base 2. Oh, okay.
Yeah, there's one,
Base
there's
1,
two.
base 2, and height.
Thank you.
Trapezoids were so
And this is going to be side.
Yes.
Okay, so here I'm going to say what? Return length times width. Here I'm going to say what?
Base.
Return
Base 2 divided by.
Yeah, base plus, base 1
Base
plus
1 plus base 2?
Yes, I think.
That's not right, I don't think.
Well, it will be, I think, in just a second.
Base 1 plus base 2
Divided by 2.
Divided by 2, yeah.
times the height.
Times
Oh, yeah.
Oh, I got a little geometry. Okay, and then what?
Times height.
Times
The
height.
whole thing, times height.
Yeah.
The whole thing.
Well, now, wait. Think of order of operations. What's going to happen is going
You're
to,
gonna need to make more parentheses, right?
maybe.
No.
Because you multiply times 2, then
The division happens first.
Y'all, think with me. The addition happens first because it's in parentheses. That means I've got a number.
Oh, and then it goes in order.
And then it goes in order because these two are on the same level. Now, if you want to put more parentheses, put them. Always do that if there's any confusion at all. And then down here, I'm just going to return,
5 squared.
yeah.
How? Oh.
No, because PAL sends me back a double, and I want an end here.
Wait,
Let me replay that. PAL sends me back a double. I want an end.
What? Oh, okay. That's how they wrote it.
All right, so let's run this. Now notice, the compiler's not confused about any of this. It'll call the right function based on the number of parameters. So if I just run this, and what's wrong? Oh, left off the semicolon. Okay. Did I do that on all of them? No. Talk about a rookie mistake. Okay, here's what I'm getting.
what the heck is that?
Well,
Did it work?
You didn't put out the.
You didn't print out anything.
Yeah, thank you. I didn't print out anything.
Oh.
So prints,
We don't have to tell them, be like, let's
area 1, area 2, area 3. That, I've got to have a prototype up here, void, prints, ints. Come down here, print, void. Int, I was just going to say A1, int, A2, int, A3. Couts. Area 1 equals area 1 indel. And then I'm going to take that and I'm going to copy it, paste it a little bit. And so then I'm going to say area 2. No. Thanks for hanging with me. Go back and look at this video. I think it might make more sense. Okay.
A1, A2, A3.
Right.
No, 'cause
The arrows.
oh, there's no arrows in between the string.
Oh, yeah,
Yeah,
thanks.
the thing.
No change.
I think it's
No change.
Words are very hard.
Okay, let's see if it works.
Maybe it'll work.
Okay. Overloaded functions.
Wow, that's beautiful.
Now, if you go on with programming, you'll be using this in object-oriented programs. For the programs we're writing, just know that it exists and what it does. Who's making the decision about what function to call? Well, the compiler is. So down here, if I just had area 1, for instance, and I said get area and send it 2 parameters, the compiler will go to the right one of these to call it.
What if you don't send it in parameters?
Let's see. That's a good question. Let's run it.
They won't let you.
Because it's not a void, right? No, that's not right. Never mind.
It says no overloaded function looks like that. Now then, could we make one?
Sure, why not?
Yeah, we could. We could come up here and say, okay, int, get area, no parameters. Are we still overloaded? Yeah. Notice difference in parameter. What if I put string here?
No, that doesn't work.
Yes, it does.
No, it does not.
And I come down here and I put Waldo.
Where is?
That's the question. And I take the rest of these out, so we don't get confused about anything.
No.
Target area is longer?
Let's see what it gives us. We haven't written that one yet.
Well, what is?
That's why with the video, you can rewind it and play it back and go, oh, after watching this 19 times, it's not confusing anymore.
Yeah, I'm have to watch it.
I don't want that. I want int get area string s. What area? What do we want to send back?
I will give you that.
I can just do that. And if I run it, now what's it not liking?
You still have, A2, A3.
Ah, yeah. Thank you. And what's it not liking? Print function does not take 3 arguments. No, my prototype is still sitting up here.
Oh.
Notice what it printed. See, I can call it with a string if I want to, as long as it makes sense somewhere. Now, this one doesn't, but I can do
Say
that.
Waldo. Like what?
I can send it any string.
Yeah.
Oh.
I'm just saying,
Fantastic.
Okay.
the point is, I can overload these things with different types of parameters, different numbers of parameters, a different order of parameters.